students. Today we want to learn a little bit about isotopes. Now isotopes are an interesting idea because it's hard for us to actually picture them. But you'll recall that the mass of an atom is made up of the protons and the neutrons that are in the nucleus. So remember, if we have 2 neutrons and we had, say, 3 protons, then we would have a total mass of 5 AMU, atomic mass units. So each proton and each neutron is 1 atomic mass unit, and that's just a tiny number that we use in order to keep the numbers even for us to work with. So the number of protons in any given element will always be the same. So for example, if this has 3 protons, then the identity of this element would be lithium. It would always have to be lithium, because if there are 3 protons, that's what it is. But there can be different numbers of neutrons in an atom, and that is what an isotope is. So an isotope is an atom of an element that has different numbers of neutrons. So we could have, and we usually refer to isotopes as the mass number. So carbon-12 would have 6 protons and 6 neutrons, because 6 plus 6 is 12. Sometimes we talk about carbon-13. Carbon-13 would still be carbon with 6 protons, but it would have 7 neutrons, and that's why we would call it carbon-13. But in this lab today, we want to figure out how we can really get a handle on this decimal number that is on the periodic table that we see. When we're using mass number, we always have to round it, because we can't have part of a proton or part of a neutron. It's always going to be a whole number, the mass. So let's keep that in mind. So the mass is the protons plus the neutrons. So what do we do with that decimal? So what we're going to do today is I have some little sacks of rice, and they are very carefully made and measured to represent all of an atom in the universe, or in the world, I should say, on Earth. So for example, let's start with these green ones here. These represent zinc. So if these were all the zinc atoms in the whole world, we would want to find out what the mass of them are, because they might not all be the same. So we're going to say for our procedure on our lab sheet, we're going to begin here with zinc. So we have, for our total number of bags, for zinc, we have 24. So you can write 24 for total number of bags for number 1. And then the element that we have is zinc. And the atomic number for zinc we can find on the periodic table. And it is, once I find zinc, it is 30. 30 is the atomic number on the periodic table. So now we want to measure the mass of all of these bags, and we're going to round to the nearest whole number, because we're going to assume that this is a single atom, and a single atom can't have a partial proton or neutron, so it's going to have a certain number. So we're going to measure the mass rounding to the nearest whole number and record our data. So I'm going to turn on my scale and begin to measure. So the first one, I have 64. So I'm going to write down 64. The second one, 64 again. The third one, 64. The fourth one, 64. A lot of them are the same. This one says 66. And I'm actually going to write it in a different column so I can count them up later more easily. The next one is 68. The next one is 66. The next one is 66. The next one, 68. 64. 64. 66, 64, 66, 66, 66, 64, 64, oops, 64, 68, 68, 64. My 64 column is getting too long. 64 again. And last one, 66. So I have mine listed here. I have my lists of 64s. It looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these are 64. Now remember, we had a total of 24. So about half of all of the atoms that I have represented here have a mass of 64. But then 1, 2, 3, 4, 5, 6, 7, 8 of them, so about a third of all of the atoms are 66. And then 4 of them are 68. So out of the 24. So now the next step, I'd like you to visually organize your mass numbers by using a stem and leaf or a dot plot graph. So I'm going to show an example of those two different kinds of graphs for this element. So for a stem and leaf, we have, it look like this, we have 60, and then, whoops, this actually, 60, and then we would have 64, 60, no, we don't have any 60, well, we don't have any 65s, I guess. We have 66 and 68. And then we would just write out the numbers. So we remember we had 12, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 64s. And then we had 8 66. So we have 1, 2, 3, 4, 5, 6, 7, 8 66s. And I have 4 68s. 1, 2, 3, 4. So that's a stem and leaf. We can also use a dot plot. So these allow us to visually compare the amount of different isotopes of our zinc atom. Now, we have 3 different isotopes. So for number 4, how many different isotopes? How many different masses do we have? That's going to tell us how many different isotopes there are. So for each isotope, in number 5, we want to calculate the number of protons, the number of neutrons. So in the table below, you'll put the mass. So the isotope mass for this one would be 64, 66, and 68. And then the number of protons, that should be easy, right? Because the protons never ever changes. So remember, our number of protons is the atomic number, which in this case would be 30. And then our number of neutrons. So use ape-man, M-A-N, mass minus atomic number is going to give you the number of neutrons. So we have mass, which is here, minus atomic number gives you neutrons. Then we want to take the percent of the total atoms of that isotope. So we said that this is a nice even number. This was 12 out of 24, so that's going to be half, isn't it? It's going to be 50%. And the way to calculate that percentage is written there in number 6 for you. So if you have 6 bags with a mass of 14 and a total of 11, then you would set up a ratio. Because these are nice and easy, but sometimes they're not. So if you have let's say you had 11 total bags and you wanted to find out what the percent is, then you would say 6 out of 11. You can set up a ratio and divide that out, and then you're going to multiply it times 100, and that's going to give you the percent. So in this case, it would be 55%, right? So you're going to calculate and find out the percent of each isotope of the whole. And then using that, we will calculate the average atomic mass. So that's, when we use the average atomic mass, that's kind of like what we see as the decimal number on our periodic table. So work through the rest of your sheet, doing the calculations to find out about how the mass of different isotopes and the number of them ends up being the number you see on the periodic table. Okay, now we want to find our average atomic mass for the atoms, the models of the atoms that we measured. So we had 3 different isotopes of zinc, and now we want to figure out, we know we had 64, 66, and 68, but now what would be on the periodic table? About half of them were 64, about a third of them were 68, and then what, like a sixth of them were the 68, 66, and then 68. About a third were 66, and then a sixth of them were 68. So we want to figure out, how would we find the average? Now you remember, if you average something, you just add them all up and then divide by that number. So we want to add them all up to begin with. Now, in this case, we had a total of 24 bags. So our total number should be, of things that we have, are 24. But instead of going like 64 plus 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 64, that's 12, right? We know that we can say 64 times 12. So I'm going to say 64 times 12, right? And I'm going to add that to, we had 66. How many 66s did we have? We had we had 8 of them. 66 times 8. And then for 68, we had, whoops, not plus, 68, we had 4 of them. So this is kind of the same as adding them all up. We're just doing it a little bit faster with multiplication. So 64 times 12, you can use a calculator, and you're going to see that it's 768. And 66 times 8 is 528. And then 68 times 4 is 272. Now we're going to add all of these up. 768 plus 528 plus 272. And we're going to get a total of, I'm not really sure, let me see what we get a total of. We have 768 plus 528 plus 272. And that's going to give us 1,568. Now, to find an average, you'll remember that we divide by the total number of things that we had, that we added up to average. So, in this case, we added up, 12, 8, and 4 is 24, right? We had 24 bags to begin with. So we're going to take that and divide it by 24. And we get 65.3. So you can write that down as your calculated atomic mass in number 8 on your lab sheet. Now, let's go back to the periodic table and see what was the mass that we had on the periodic table for zinc. So zinc, we have 65.3. It's 0.38, but pretty close, right? So 65.3. So basically, these are the isotopes. These 64, 66, and 68. These are like the isotopes as they occur in nature. So about half of the ones in nature are going to be 64, but some of them are 68, And so when we average them all out, that's how we get that decimal on the periodic table. So hopefully by averaging them out yourself and by seeing how different masses of the same thing, so these are both the same element, they have the same identity, but they have different masses, that represents the isotopes in the atoms.